A few months ago, I built this prototype for a coin pushout module. It used an Arduino Uno, but it wasn't the sleek, integrated solution I wanted. Thanks to NextPCB for sponsoring this video, I was able to design and manufacture custom PCBs to turn this into a professional product. NextPCB is a PCB manufacturer with an easy-to-navigate website and excellent customer service. When my order arrived, I discovered an assembly error. But this was completely my fault from the ordering process. Most components were pre-soldered, but several were missing. Because in the ordering process I didn't read it very good, so yeah. Fortunately, I am very good at soldering. I grabbed my hot air gun and got to work. The solder was already on the board, so I carefully placed each IC and component on the board and soldered it with my hot air gun. Then I inspected the PCB under my microscope. I noticed the USB-C port needed cleanup, nothing some desoldering wire couldn't fix. And I also soldered the rest of the through-hole components on the board. And then I tested a bit with my multimeter if everything was connected and soldered good. Everything looked good, so I put my USB-C in and I got 5 volts and 3.3 volts and the LED lighted up. But when I plugged it into my PC didn't recognize the device. Since the programming chip handles USB communication, I knew this was the issue. I soldered and desoldered this IC a couple of times before I realized I maybe needed to look at the schematic. And when I looked at the schematic, I saw a stupid mistake I made. I connected the power pins of this IC to VCC in the schematic, and the rest of the PCB was connected to 3.3 volts, which meant 3.3 volts and VCC were not connected to each other. Luckily, I can just solder a wire between the VCC and the 3.3 volts. And this should fix the issue. And when I plugged it into my PC again, everything worked. It recognized the ESP. Then I wrote some test code for the PCB that uses all the functions I have integrated in this PCB, like the RGB, the servo motor and the buzzer. With the button press on the side, it turns the servo 180 degrees and back, so it ejects a coin. And I also set up a web server so I can control it over Wi-Fi. Next, I designed a custom enclosure in Fusion 360 that integrates with my existing coin pusher mechanism, creating one complete professional looking unit. After assembly, the final result worked flawlessly. I can even control it from my phone. Check out NextPCB for your own PCB projects. Bye.